This building keeps the college warm through the winter. Inside are boilers that turn tons of water into steam every hour. And this boiler was installed for a project that never actually happened.
Hello, this is Jason from Steam, Electricity, and Propulsion, and today we're going to see how the Burnham Scotch boilers provide steam to the Valley City State University.
In the main room, you'll see a large and small Scotch boiler. They are rated at 24,000 and 12,000 pounds per hour, and they usually burn gas. The hot combustion gases pass back and forth 4 times until the exhaust leaves the boiler at about 350 degrees. This is slightly higher than the boiling point, which means these boilers are efficient, achieving approximately 85% heat recovery. The steam consumption of the campus is only about 6,000 pounds per hour at the moment, and the large boiler is at a 25% load. At low firing rates, the flame appears more yellow and diffuse, which is typical in large industrial boilers operating well below their maximum capacity. To burn the gas, there is a 25 horsepower draft fan that blows air into the furnace. To control airflow for different amounts of gas to burn, there are dampers since the fan constantly runs at 3,500 RPM. Now let's see where the water to make steam comes from. In this room, there is the steam pipes and condensate return line. Vacuum pumps pull 5 inches of mercury to draw water back from the buildings. When the tank fills up with water, a small pump kicks in to empty the tank. You can see the water slowly draining through this glass tube. The water is pumped to a small storage tank where softened water can be added to replace lost steam. Underneath the tank are centrifugal pumps that push the water into the deaerator at 7 psi. The deaerator removes dissolved air by heating it to boiling point with steam. Now the water is hot and pure, and the feedwater pumps are right here. There are 3 of them, but at this low steam demand, a 15 horsepower 90 gallon per minute pump can handle the load.
This water would drop below that other line right there. It shuts the boiler down.
To control the water level in the boiler, there is a feedwater regulator that works using a float to measure water level.
Does it open the valve just on and off, or does it open the valve variably?
Variably.
Okay.
Right now this valve is open a little ways. Letting water through.
Based on the position of the float, the regulating valve will adjust water flow into the boiler, keeping the boiler full of water. This is the coal-fired hybrid type boiler. At the front of the boiler is the stoker. And this is the secondary air fan. Here is the bag filter, sulfur scrubber, and third scrubber stage. Here's the induced draft fan and the tall smokestack. You can see the soot blowers here. This is the coal elevator which lifts coal into the bunker. This coal-fired boiler was installed to support a plan to produce activated carbon, material similar to charcoal but processed to have a much higher surface area. The plans were to build a building off to the side to manufacture the carbon, and the coal gas, a byproduct of charcoal production, would be burned in this boiler. The project has not been completed because the cost of shipping coal is expensive because there is no railway access to the plant. All the coal has to come by truck, which is expensive. Even though this boiler never ran the way it was planned, the rest of this building works every single day to keep the campus running. The boilers produce 100 psi steam, but the buildings don't need that much pressure.
Return pump room. And turning those up or down will increase or decrease the pressure.
These regulators reduce pressure to 50 psi on the lower pipe and 15 psi on the upper pipe. The heat plant also needs heat. They actually use hot water and not directly steam. These pumps circulate hot water through a steam to water heat exchanger. The air compressors supply air to automatic controls, power tools, and occasionally air blast oil burners. If the gas supply became compromised, these boilers can switch to number 2 diesel fuel. First, the oil is filtered, then goes through the pump. The pump moves more oil than the boilers need, so extra oil goes through a spring-loaded bypass valve. This keeps the oil pressure steady, while the regulator valve meters exactly how much fuel enters the furnace. Here, the compressed air goes in and blasts the oil into a mist that is highly flammable. The boiler room is critical to the college campus, and it has to be able to produce steam at all times, even if the power goes out. Behind the plant is a diesel generator. This room houses the transfer switch that automatically connects the generator to the plant during a power outage. New videos will come as I get access to more places. Quality over quantity.